Welcome to another adventure in old guy physics. We've got this topic that we're covering this fall, and it has to do with reading and interpreting information off of graphs. This first graph that I want to show you, I want you to notice that it's a distance versus time graph. And so there's information that we can pull off of this graph that's important, and it's relatively simple. You just have to follow a couple simple rules. Number one, I'll put that right here. Number one, we want to figure out what the slope is going to be for the various line segments that are on the graph. The slope is going to give us the velocity. So if you remember the simple formula for slope, which could go back all the way back to rise over run, if you will. For example, right here, we have a run of 4 and we have a rise of 20. So the slope would be 20 over 4, which is going to be a positive 5 meters per second. You should also remember from your math class, at any place that the slope is flat, where the line segment is flat, then the slope is 0. So 0 here and 0 here. Now, it's important for you to know that when you have 0 slope on a distance time graph, what that's telling us is that the object, the person, whatever it is that's moving, that created this graph, is not moving, it's standing still. So for this many seconds, right in here, it's standing still. For this many seconds, right here, it's standing still. Now let's take a look at that last line segment. Right here, it's going down 10, and it's going over 2. So 10 over 2 is going to be 5 meters per second. But because we're going down and to the right, this is negative. And so the slope's going to be negative. One of the things that we talked about in class that's a good reminder, positive slope gives you positive velocity, which means we're moving to the right. Negative slope indicates that we're moving back to the left. Another way of looking at it is we started at the origin right here and we moved away from the origin. Whereas here we're at 20 and we're moving towards 10, which is moving back towards where we started. One of the things that I showed a student yesterday afternoon was, let's pretend like there's a guy right here, and he starts at the origin, okay, the starting line, and he's going to walk out to 20. So now he's here, and it took him 4 seconds to do it. Then, for 4 more seconds, he stood still. Then, in 2 seconds, the same guy had to turn around, and he walked back to 10 in a total of 2 seconds. So basically he was moving the same speed, he was just moving in an opposite direction. And the last 2 questions that were asked about this graph on the homework was, number 1, what was the total distance traveled? Well, if you look at my diagram over here, you can see that he walked out 20 and then he came back 10. So the total distance that he walked was 30 meters. The next thing question that was on the worksheet was, what was the person's displacement? The displacement is the distance from the starting point to where he ended up. Well, if the guy ended up right here because he walked back 10, then this distance right here is his displacement, and the displacement on that particular graph would be 10. Now, if you have any questions about this particular problem, talk to me in class. And you all have a wonderful day. Amen.